All right. The schedule's a little different than what I had on my website over the weekend. I am going to have a test on Friday. Here is, here are some various homeworks. There are 4 homeworks here. Hopefully you have one of each. I know I say this a lot, but this time I really mean it. I would like to get caught up on homework, so we basically do homework the way you should do homework, which is I teach you something today, you practice it tonight, you learn from it tonight, you ask the questions about it tomorrow, and you turn it in tomorrow. Therefore, I want you to do tonight's homework tonight. First, if you're backed up on homeworks, put it off. Do tonight's first, then if you have time, do set 47 or whatever you haven't turned in yet, but do tonight's tonight. Have it done tomorrow, the way you should. Understood? Good. Okay. Test is on Friday. Hopefully will be good. The test is through set 49. That includes some real humdingers like fundamental theorem and second derivative, concavity, inflection points, second derivative test, related rates, trig derivatives. Phew, that's a lot. Today's lesson is not really a lesson per se, in that it's just a skill that you should be able to, with practice, get good at by trying it on your own and looking at whether you did it right or not. So, towards that end, rather than notes, let's just go straight to tonight's homework. Let's go with number 9 only. I know I have 8 up here, but I'm going to go to 9. Number 9 is to take the derivative of g of t equals sine of 2t over cosine squared t. Now I know you might feel like, is that new? And you might say it's not new because we've already done the rules you would need to do this derivative. What are they? Quotient rule and chain rule, okay? What's new is they're now putting these together, I guess, into one problem. So, try to keep it organized. Do the chain rules subsumed within well, and we'll go over it in a minute. Give it a go, please. Darn it. So you go. Tell me what's going on at y or x equals 1/8 plus root 33/8. Given that we said that was about 7/8, that puts us in this region here, yeah? Say your conclusion, we'll go over it in a minute. You could actually probably put these together. We could do plus or minus together because it's the same number. Okay. Ready? All right. Y has max at x equal negative or 1/8 plus or minus root 3/8 because y prime equals 0 there, and y double is less than 0. Rather than write that big mess, I typically just say there, but you can definitely write the big mess. Okay. Okay. So, second derivative test, check. Would you go to box 25, please, on tonight's homework? Do you know your 6 trig derivatives? Without your notes. Let this be an indication of whether you need to study a little before the test. Do the 6 trig derivatives. Actually, I gave you one. Do the other 5 trig derivatives in box 25 of tonight's homework. have to do them in this order. Okay, cosine's derivative, what is it? Tangent's derivative, what is it? Cotangent's derivative. Negative cosecant squared. Secant's derivative. Secant tangent. Cosecant's derivative. Negative cosecant cotangent. Now, surely you could develop those if you had to on a test, but boy, would that be a time. It's better to have them down cold. All right. Last thing I want to hit real quick is number 21. Go to 21. Okay, in step 47, we talked about the fundamental theorem of calculus, which is a way of finding area under a curve without the infinite rectangle, but I don't want to leave the infinite rectangle in the dust. So you get this problem here. They give you this expression, the limit as n goes to infinity, blah, blah. It's meant to represent an area under the curve calculation. Would you please write that expression in summation notation, please? The exact equivalent of that, but with sigma. This is starting to be more common on the AP. I expect this to go badly, but we'll see. So, in summation notation. First of all, did I do anything to the limit? Does this still need to be there? It does. Okay. Now this one over n is not really part of the sum, so it could be out front or within the summation. Did you write it out front of the sigma or inside the sigma? I heard a little of both. I wrote it inside, but whatever outside is fine. Okay. Now then, when I do this, I say, okay, what's always the same, what's always different? What's always the same is over n, over n, over n. So every time I have over n. What's different is where the counter comes in. I'm counting 1 plus 2 plus 3 plus 4, and so on. So that must be the counter. I call that I. All right? 1 over n, 2 over n, 3 over n. What does 1 over n start of? How many 1 over n's do I start with? 1. How many 1 over n's do I end with? N. So this would be the first 1 over n, the second 1 over n, the third 1 over n, through the nth 1 over n, which is 1. So it ends at n. Yeah? All right. Now then, all this summation notation is ways of saying rectangle areas, where the base is delta x and the height is the function at some x. Yeah? The function is always at some x generated by going over so many delta x's. What going over, starting at 0 and going 1 delta x over, then 2 delta x overs, and then so on. Unless you don't start at 0, in which case you have to say, oh, I'm starting at 1, and then I'm going over 1 delta x, 2 delta x's, and so on. So there's all these different things going on inside the summation. But this whole idea, taking infinitely many, is this if I have this region, one wide or whatever, and I divided it into n chunks, and n gets bigger and bigger, then doesn't each base get smaller and smaller if I divide it into more and more chunks? And so delta x starts to approach the more theoretical. This becomes yes. Yeah, what about the first part? What's the function? This says I'm putting in a 1 over these terms. So I put in a 1 over n and I get out a 1 over n. I put in a 2 over n next. When I put in 2 over n, I get out 2 over n. So it seems like the function of whatever I put in is the same as what I put out. So it is just x. And finally, the limits of integration. What's the limit of integration? Most students do fine with that. 1. What about the lower? Jared, how do you know? What does this tell me here? The original region is how wide? It's 1 wide. Okay, and I divided it into n chunks. So if I'm ending it in at 1, and I know it's 1 wide, then it must have started at 0. Okay? All right. Now, I have a definite integral set up. You should be able to evaluate a definite integral. What are the 2 steps to evaluating a definite integral? Integrate or anti-differentiate. What's the antiderivative of x? 1/2 x squared. Remember, when you anti-differentiate, you raise to the power, divide by the new. Evaluate it from 0 to 1. And then we evaluate it at the upper minus the lower. So that's 1/2 times 1 squared minus 1/2 times 0 squared, or geometrically, what does that correspond to on the graph? The area of a triangle. Yeah? Wouldn't the area of that be 1/2? Wait. Because y equals x is a linear. From 0 to 1, we get a triangle. Base of 1 and the height of 1. So that's a reasonable answer. All right. I was going to do a related rates question, but in the interest of time, let's get questions on 48, 49. 48 and 49 are due today. So tell me, first of all, what questions do you have on 48? 48 was so brave. 48 so much fun. So you need, I don't know if I finished the replacement problems on the original key, but on the back. But I can tell you that replacement answers are thus. Number 3 is f prime at pi over 6 is undefined because tangent is undefined there. That was a dumb problem. F4, or number 4, is pi over 2. Number 5 is secant of x plus c. Number 6 is 1. Don't have 16 done. I'll have to come back to that. 19 is f is increasing on 3 to infinity. F is never decreasing. Actually, that's because f prime is greater than 0. Never decreasing because f double is never negative. And as far as a minimum, that's actually for a later day here. But if the function starts at a domain of 3 and the derivative is positive after, then the function might look something like that. Well, what's going on at 3 is that there's nothing less than that, so that must be a. Now, endpoints are a totally different animal. We'll talk more about that to come, but you would get that x equals 3 is a minute. And then on the practice on recent ideas, I put those on there because the critical number, the pre-calculus of the solving was disastrous on the last test. I want to see improvements. So on A, the domain was x is between -2 and 2, the derivative is -2x over 2 root 4 minus x squared, and the critical numbers are 0, 2, and -2. For b, the domain is x is less than -1 or x is greater than 6. The derivative is 2x minus 5 over x minus 6x plus 1. And there are no critical numbers within the domain. C, the domain is x cannot be 3. The derivative, this should have been g prime, sorry. The derivative was something like e to the x minus 3 minus 1. Oh, no, my bad. -2 e to the x minus 3 over e to the x minus 3 minus 1 quantity squared. And there were no critical numbers there. And d x cannot be plus or minus 2. A prime is factored e to the x times x squared minus 2x minus 4 over x squared minus 4 quantity squared. And the critical numbers are x equal 1 plus or minus root 5. Okay. Now, questions on set 48? Okay. Yes, sir. Oh, you're raising your hand. That's good. 2 and which? 2 and 13? Okay. 22. Okay. Let's call it there so we can have some time for 49. All right. Let me go back here. Okay. I'll maybe put one up here. All right. Set 48, number 2. Oh, man. So if you're a killer at these, you might do this one of two ways. If you are a chain rule master, you could do this in a fun kind of chain rule way. Most students shy away from it and do it the long, harder work way, because at least they know what they're doing. But the problem is you've got this water balloon here, and they're putting water into it, it's remaining a spherical shape. And all that's great. They give you dVdt. It seems like a straightforward problem. Is positive 2 cubic centimeters per second. But the problem is they ask you about dA dt, the surface area change, when the radius is 7, yeah? Now, the typical approach that students tend to want to do is to say, all right, I can't go straight from volume to surface area. So what's an in-between concept? Yeah, so you go with volume to find the rate at which the radius is changing, then use dr dt for the surface area change, yeah? Now, I will be happy to do it that way, but again, for the top end of you, let's just throw this out there. Okay, chain rule. Big boy chain rule, okay? You want dA dt, yeah? Now, you know dV dt. You could start there. All right, now, I could then use dV dt. It's kind of like this, but it's a lot less work. I could use dV dt to find dr dt, right? Now, to do that, I would have to cancel out how v is changing, so I'm going to put it down here, and get how r is changing, and that would be up there. Now, at that point, that would have how r is changing. You follow? Now from there, I can find how area is changing by getting rid of radius and seeing area. And as far as what's left standing there, dA and dt. You see? Now, dV dt, what is it? It's 2. Okay? Now here's where things start to kook people out. Check this out. dr dv. I think you'll agree that that means taking derivatives on a VR equation. The part that kooks students out is how you take the derivative. Now, normally we would take dv dr, the derivative of this equation with respect to r, because it's the independent variable, right? But if I want dr dv, then I'm actually going to take the derivative with respect to v. If I take the derivative with respect to v over here, what's dv dt? 1. Okay? Now on this side, I'd have 4/3 pi times 3r squared, but then the derivative of r with respect to v, which is dr dv, yeah? Now I want to sub in for dr dv. What's dr dv? 1 over 4 pi r squared. Cool. Now, I need dA dt, now, or dA dr. Surely that involves my area equation like this. And differentiating with respect to r, right? So dA dr is what I want. I'm going to get that on the left. And what's the derivative on the right? With respect to r. 8 pi r dr dr, and so done. Now that then is, notice the pi's whoosh, go away, and 4 goes into 8, and then r goes away. And so I get something like 4 over r, which is 7. Done. Now the alternative is this way, and I'm happy to do it that way too. And after about 5 minutes of work, you can get there. But if you asked a math teacher, that's how they would do it. Because it's less work. Okay. 2. Boom. 13. Question on 13. Is that still a question? Whoever asked that? Okay. 13 is this replaced anywhere or just straight away from this? Okay. G is a function where g prime at 2, they give you g prime at 2 equals 0, so I know g is flat there graphically. G double is, or g prime is less than 0 on 0 to 2, so that implies g is decreasing, right? And g prime is greater than 0 on 2 to 4, which implies g is increasing. So local maximum, and I asked you to sketch. I think that should help. So I know the graph goes flat at 2. And before, because the derivative is negative, it was decreasing before. And because the derivative is positive after, it must be increasing after. G must be increasing after. So with that, boom. Mid. Cool. 22, question on 22. Is that still a question, somebody? All right. Do not use your calculator, break into little pieces first. This is a rational function we are yet to do, but this is the same as x plus 1 over x. So this, if you were to graph this, it has a vertical asymptote at 0, but it has a slant asymptote at x plus 1, and the graph you'll see looks something like this eventually. You do not need to have that down. But my point is this. Don't use a calculator. Find the relative max. Well, I could do the quotient rule here. I would prefer that you do the derivative on this, which is easier. 1 plus 0 minus 1 over x squared. I want to know whether this is 0 or undefined. 1 minus 1 over x squared equals 0 or undefined. If I get a quotient, or make this a fraction, I get x squared minus 1 over x squared equals 0 or undefined. Critical numbers, f prime is undefined at x equals 0, but is that a critical number? In the original problem, x equals 0 is not in the domain. So by domain, it's f. F prime is 0 at x equal plus or minus 1. Now, if I were to go to sign test on this, it's a little easier here because I have the graph looking at you. But if you were to do this, I want to know how the derivative is changing sign. And although that 0 didn't pan out as a critical number, it could actually have an effect on the sign. So you should, although 0 got dumped, you should include it in your sign analysis because you can change sign at that. So if I were to look at this, then surely at negative 10, I'm looking at negative, negative, positive, so that's positive. F is increasing. After negative 1, I'm talking, or less than negative 1, I'm talking negative, positive, positive, which is negative, so decreasing. Then it has an asymptote. After 0, maybe at 1/2, negative, positive, positive, still positive, so increasing. Negative, dummy, sorry, my bad. Negative is decreasing. This one's the least. Decreasing. And then after 1, positive, positive, positive is increasing. So answering the questions, where's the max? Where do I go positive to negative on the derivative? And that's at negative 1. Do they say, what is the maximum? The coordinates. They want coordinates. So I have a max at negative 1. Here's the original function. At negative 1, I'm looking at 0 minus 1, so negative 1, because f prime changes negative to positive, or positive to negative. Okay. And 19. Question on 19. You're good? Okay. All right. Set 49 questions. Let's go to set 46. 26 is what I meant to say. 26.
I'm just what were we supposed to do?
26 you can skip. I eliminated 2 boxes and then I got to move the instructions to box 26. So 26, my bad, you can skip there. In terms of replacement answers to set 49, number 4 was F has an inflection point at x equal 1 because F double changes sign there. The next replacement is 23. First derivative tells you increasing, decreasing, or flat, I suppose, also. Horizontal tangent. B, second derivative tells you about the graph, concave up, concave down, or I guess you could also say whether the slopes are increasing or decreasing. And then the last one, the function has those points, and if the derivative is positive, f at a, the point where they left off, must be greater than 6 because f is increasing. so it needs to increase. The next one, if the second derivative is negative, then f of a must be less than 12, because f prime is decreasing, or the changes are decreasing, or f prime is increasing at a decreasing rate. One of those connections would do it. And then 27 is f has inflection points at x equals 0 and 2, because f double prime, changes sign there. Okay, other questions on 49? Yes, ma'am? 1, 7. 1 and 7 is good stuff. Okay. Strangers in the room. Yes. Okay, number 1, you've got a cone. They gave you a picture in the book, so you didn't need to redraw it. But just so I have it as a reference. Notice in the original cone, the radius height is 5 and the height is 5. That's beautiful and wonderful, and for that I am very grateful, because that's going to make my life a lot easier. And so, all right, now that's the cone itself, not the water. The water is going to have a varying radius and height as the volume changes at time. Did you write the givens? It says the radius, let's see, whose base is the water is dripping out at a rate of 1 cubic centimeter per second. So you're given dV dt is negative 1 cubic centimeter per second. In my rubric on a test, that's the first thing I look for, right? It's given. Then I would say, did they express what they're trying to find? Yes, Hibby.
Could you write dt over dt equals question mark at d equals 5?
Yes, absolutely. The order in which you give these is up to you, but I definitely would expect them to be up front and center at the start of the problem. D equals 5. When d equals 5, is that the instant? Okay, so at the instant it's about to overflow. How fast is the depth changing? Ooh. Oh, maybe not. Depth is 2 meters. Oh, they're not equal. I drew my picture wrong. Sorry, this is 5. My bad. Okay. When this is 5, this is 10. They're not equal. I apologize. All right. So, wouldn't you say that the volume is pi over 3 r squared h? Or d, I guess, if you're using depth. Okay. Before I bust out the calculus on 3 variables, if I can help it, I'd rather get it down to 2. Consider the original shape here. The original shape was a 5 radius to 10 height. So generally speaking, isn't the radius always going to be half the height, or the depth? If it conforms to the shape of the cup, it's always going to be that way. Now then, I can use that to substitute and get it down to d only if I plug that in there. Does that get you going? Okay. So maybe work with pi over 12 d cubed and you'll be rolling. Okay. Check 7. Question on 7. Is whoever asked that still awake? Cool. 7. All right. We've got this cube shape, and x cubed minus x plus 2, x cubed minus x plus 2, x cubed minus x plus 2. All right. The part of the issue is getting through this successfully without calculation error. I assume you set up a definite integral.
Hello, happy Happy Monday. Today there's a high of 61 and a low of 44. It will be sunny all day. Even though it's not ready right now. Please rise for the Pledge of Allegiance. Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
All listeners, 11th graders with last names I through N come to counseling today for 7th hour to meet with their counselors for a case study.
Dad, please remember, if you are feeling sick or think you need to go home first, check in with the health care, formerly known as the clinic. You will discuss with Ms. Castillo how you are feeling before calling or texting your parents.
So I don't do this by getting
Just a fun
simplifying
fact
this
about
in.
the University of Colorado.
This is what my work
Let's pray. My body sings electric and use me in Apollo or a few bands that have cut records for your College of Arts and Media. Interested in learning more about CU Denver? Reach out with them today during the 7th hour. Sign up on Knobshot.
The Latin American Educational Foundation Scholarship is open to those who are of Hispanic heritage and are actively involved in the Hispanic community. The deadline is November 20th. See counseling for additional information.
The American Legion George C. Evans Post 103 Scholarships in Littleton, Colorado is offering 8 $1,000 scholarships to students who are descendants of an honorably discharged veteran and either related to a post member or live in the post-service area. Stop by counseling for the application.
Hey guys, make sure to follow Dublin's official social media pages at Dublin Junior Senior on
Even though if you need me to put
Instagram, at
something else
Dublin
up.
Junior JRSR on Twitter, and /Dublin JRSR on Facebook. We will be giving away awesome prizes all week to randomly drawn followers, so be sure to follow and like us and listen to the announcements.
Jack, do you have any pictures of yourself enjoying Colorado? Yearbook needs pictures of you skiing, cheering on Colorado teams, and enjoying all that this awesome state has to offer. Send your pictures to yearbook.jags@yearbook.com.
Junior high students